I was wondering if you could talk a little bit more about just what's going on in the macro environment of the cloud, the world of cloud. And I think ultimately to get to the point of what can an engineering leader who's responsible for controlling these costs do in this sort of macroeconomic environment. And so can you help orient us there and help give us a little bit of a guidance on how can we navigate this as engineering leaders?
Yeah, so like that's the thing I worry about, that other than getting really efficient with your use of resources, it's going to be hard for an individual team or a leader to impact, kind of macro trend.
Mm-hmm.
And it's a very deep topic. So maybe at the highest level, we are, if you've tried to buy a car, you kind of see this. We're in a chip shortage, right? You can't get chips for a lot of the common devices that we want to buy out of our supply chain. Part of that, it was a COVID issue where factories were shut down. Part of it is a kind of a global economic issue, and I'll explain what I mean in a second. Most of the rare earth material that we use and the refinement of that, and then the actual chip foundry, like the thing, all of that is made in a very specific part of the world. In fact, Taiwan Semiconductor is a company that makes the vast majority of the chip capacity that we have globally. The problem is that Taiwan is a disputed area of the world. China believes it belongs to China. Taiwan believes that it's an independent place. And we, as a kind of Western society, have said this is a very dirty process. It takes a lot of water to produce chips. So let's not be in that dirty business. Let's let others take care of it for us. And that was a huge mistake. So we're in this very tough spot where we've got Taiwan, like we don't know what happens to Taiwan in the next 1, 2, 3 years from a macroeconomic and global geopolitical perspective. It's a hot potato. And in a lot of ways, Ukraine is the canary in the coal mine for China. Like it was a perfect test case to see how the world would react to a perceived aggressive move from a totalitarian government into a contested area of the world. So depending on how kind of Ukraine unfolds, we don't know what will happen to Taiwan, and we're on our heels as kind of the Western part of the world because that we desperately need that capacity until we can ramp up capacity in other places of the world. And they should be the United States, Canada, Mexico, like West. They should be in Europe. They should be in India, etc. We need to diversify. Like any single point of failure in any supply chain is a massive problem, and that is what's leading to temporary inflation of computer prices, like of chip prices. Now, some of that's alleviated over the last 30, 60 days, but it's still a massive geopolitical problem, one that's unraveling. And it's not something that you can deal with as an individual engineering leader. Like if there's no capacity, there's no capacity. But what you can do is you can make sure that you're using the least set of resources possible to deliver your software. And a really good case study for that, Patrick, was Tesla. Like they continued to ship cars while the rest of the industry suffered. Why did they do that? Because they were agile enough to say, well, we've got these 10 chips, let's say in the car, we can repurpose 3 of them to do X instead of Y, and let's just be nimble about it and let's do a software update. And that's going to allow us to keep shipping. I think lessons are learned from that type of agile environment where, oh, I thought I needed this many thousands of CPU cores. Well, maybe I can do with a fraction of that and be more creative in terms of how I can solve the problem efficiently.